I think these things are made of plastic. Oh, hey. You ever think about water? Well, it's high time you should. Water's weird in a lot of ways. Don't believe me? Come on over here to Building 12 in the ground floor. District 12, represent. Check out the water wall. It's like a water wall. And if you donate enough money to the foundation, you could have your name put on it. That's what I call trickle-down economics. 4-3 to the chemistry lab. Has anybody ever asked for this certificate of maintenance on file? I think I might. Okay, we're here. Thanks for watching Science with Mike. Today we're going to talk about water, and water's weird. Why is water weird? Because it's something we call polar. What's polar? When two non-metal atoms make a bond, it's like two people in bed. Not like that. No, I mean like if there was a blanket and they were sharing a blanket, that's like the electron cloud. When that sharing is equal and there's equal distribution of the electron cloud, that's what we call non-polar, and everything's equally negative. But if you have two atoms which share unequally, then you have an unequal distribution of charge, and that's what causes poles. There are charges on molecules, and those molecules stick to each other much greater than the ones that don't have charges. Here's water. Oxygen and hydrogen are the atoms involved in that bond. And you'll notice because it's bent, you have a separation of a negative side of the molecule and a positive side of the molecule. On the other hand, carbon and hydrogen, they share pretty equally. And so there's no charges really to speak of on a molecule of methane. So these molecules are stickier, which explains why water is a liquid and methane is a gas at room temperature. Don't believe me? Let's go show you right now. What I've got here is two burettes. These are things we use in the lab to dispense liquid. And in one of the burettes I have hexane. That's just 6 carbons and 14 hydrogens, non-polar. And then I've put some water in here. And what we're going to do is pour them out through this bottom part of the burette. And we're going to put a charge on this plastic rod with some fur. And I hate to say this, but I think it was an animal. But hey, it was here when I came, and I didn't do it. You'll notice that this stream of water is pretty much unaffected by anything I do. But if I switch over to the water, which remember has charges on it, I can deflect this beam, or this water, go right out. Ooh, right out of there. Ooh, that's embarrassing when that happens. See? Bend in that stream. Charges attract other charges. Nifty. The next weird property of water, which is caused by it being polar, is called surface tension. That's the skin that happens on the outside of a drop or in a bead of water, and why water beads. And that's due to these polar forces of how they're attracted to each other. But really what's going on is in the middle and the bulk of the liquid, they're being pulled from everywhere. But at the surface, they're being pulled up. And that makes it a little denser on top. I'm going to show you by pouring out some, or making drops of some water, which has a high surface tension, and some methanol, which has a very low surface tension. Next, what I'm going to do, I'm just going to take this medicine dropper. You got to fill it with water, Mike. Don't have any water in there. Next, I'm going to just take this medicine dropper and make a drop, which, you know, we're all familiar with. But you'll see it's water here. This is water. And it beads like that. And the reason it makes that bead is because of surface tension. Now, by contrast, let's take something with a very low surface tension, which is not as polar as water. and that's methanol. See? It sheets. And it just kind of spreads out to a greater extent. Here's another proof of surface tension. If I take this here beaker, and I'm really, really careful, we all know that this paper clip, no matter what it's made out of, is going to be more dense than the water. And if I try to be really steady, I only drank 6 cups of coffee today. Check it out. That paper clip is basically suspended there on top of the water, even though the water is less dense, due to the fact that it's got a much greater surface tension. Marvy. Now here's the thing. Surface tension can be altered by mixing different things in with water. And one of the things that'll do that are surfactants, and those are soaps and detergents. So what I want to do is to prove to you that I can lower the surface tension by getting in the way of the water molecules by just really gently putting some liquid soap and bang. That's it. Notice I didn't do it near the paper clip or anything. That was just something that disrupted the surface tension of the water. Once again, we have a guest, kind of our resident skeptic of science, Sid. Hey Sid, once again, really great to have you. You're always welcome. And I like your sign. It says surface tension sucks. That's true too. That's called capillary action. Whatever. Well, don't you believe in surface tension, Sid? No. I got 3 words for you. Computer, graphics, imagery. That's what surface tension, that's everything you're doing. Well, look, I think I can prove you differently. Do you know how to swim? Not really. I just float. Because of the density, right? No, I don't believe in density either. Look, let's just see if you can swim. I'm going to show you how. With water. Bring it on, science boy! This is something called lycopodium powder. It floats on water. That burns too. I just wanted to keep our fire quota. We always have a quota for fire on Science with Mike. But if I put it on top of the water, it'll float right on the skin of the water. And then I'll show you how I can sort of interrupt the surface tension. See it floating there. All right, and so what we got is a layer of liquid, a layer of lycopodium powder sitting right on top of the liquid. Now I'm going to just really gently try to put a drop of liquid soap. Bang. Totally breaks up the surface tension. See? And that's the action of getting in the way of those water molecules. All right, Sid, here's what we're going to do to you, buddy. We are going to put some swimming shoes on you by dipping your feet in liquid soap. And then you're going to scoot right ahead in that water. You ready? Oh, I guess so. Watch him scoot. Woo! Yeah, I am swimming. Okay, Sid, you want to sign off for us? I guess. Thanks for watching Science with Mike. I guess surface tension ain't that bad. See you later.